All right, so here's a little more complicated redox reaction. And let's look at how we would analyze this one and figure out who's oxidized and reduced. Remember, when we're oxidized, that's loss of electrons, right? Because that's LEO. LEO is loss of electrons, is oxidation. And then we have LEO that says GER, gain of electrons, is reduction. So what we're looking for in this equation is we're trying to find one element that is losing electrons and one element that is gaining electrons. And you'll notice we have how many elements here? We have 1, 2, 3, 4 elements. We have copper, hydrogen, nitrogen, and oxygen. And of course, they're arranged in different ways over here, but 2 of them are going to be changing their oxidation numbers, but 2 of them are not, because we always just have one thing being oxidized, one thing being reduced. The other 2 can't be changing. So the way we do this is by assigning oxidation numbers. And then we look to see who's changed. So let's just assign some oxidation numbers and go from there. So we'll start with our left-hand element. We have an element by himself. An element by itself with no charge listed means he's just by himself with nobody else around. There's nobody to share charges with, so he has to be in his elemental state, which is 0. It's just a copper wire, a copper pipe, a copper brick, I don't care what, but he's a piece of copper by himself with no charge. He's got an oxidation number of 0. Now we've got to go on to nitric acid and figure out what oxidation number we have for each of those elements. And we start out by doing the typical thing of assigning -2 to the oxygen, +1 to the hydrogen, and then the nitrogen in the middle has to make up the difference. What is it going to be? So we have 3 -2s. That would be -6, right, altogether, each one together. But each one of the oxygens is a -2, so that's what we have to write. -2, -2, -2, and a +1. How do we make this whole thing add up to 0? Because there is no charge listed up here. Well, that would have to be a +5. +1 and a +5 makes +6. -2, -2, -2, -6 adds up to 0. Okay? So we've got all of our oxidation numbers assigned for our reactants. Now let's go to the products. So we can do this a couple different ways. We could figure out the nitrate as a group and add that up to a -1 because we know nitrate as the ion adds up to a -1. Or we can take this whole compound and say the whole compound adds up to 0. Both work fine. We do know that the oxygen will be a -2. There's 3 of those. The nitrate has to add up to a -1. So what does the nitrogen have to be to make that happen? Well, it's going to have to be a +5, right? +5, 3 -2s, that whole nitrate adds up to a -1. The other way to do that is to count how many nitrogens you have altogether, how many oxygens you have altogether. You know that the copper has to be a +2 because that's his ionic charge. And you could just add the whole thing up to 0. It's a little more complicated, but it works just fine as well. Moving right along, we have our nitrogen dioxide molecule here. Oxygen always gets to have his way because he's the second most electronegative thing in the universe. The only time he has to debate that is with fluorine or in peroxide. And so -2, what does the nitrogen have to be to make it all add up to 0? Oh, you're right. You said +4. You got it correct. Okay. Oxygen, -2. Hydrogen, +1. Hopefully that is pretty clear. So now we've got all of our oxidation numbers assigned. We're all doing great. Let's figure out what has changed. Okay. So let's just start from the left. Who changed? Copper. Did copper change? Well, copper only appears once on either side, so it's pretty easy to compare copper to copper, and I would say that is a definite change. So is that loss of electrons, or is that gain of electrons? Now, electrons are negative. If you gain electrons, you have to go in the negative direction. This is definitely not going in the negative direction. It's not gaining electrons. It must be losing electrons. So we can say that copper is oxidized. So that one was really easy. Now, let's look at the next element, hydrogen. Hydrogen's a +1 here. The only place we can find hydrogen is over here, and it's a +1. Hydrogen didn't change. Not oxidized, not reduced, nothing happened. Okay? What about, let's skip over to the oxygen, because I know it didn't change. -2, -2, -2, -2. Okay, it didn't change. We're great. Okay, so oxygen also didn't change. So hydrogen and oxygen are our non-players in terms of redox. But nitrogen is going to be our guy. So let's look at him a little more carefully. We have nitrogen here as a +5. We have nitrogen here as a +5. I have nitrogen here as a +4. So some of the nitrogens didn't change, but some of them did. That's enough. That's fine. Okay? So we can say that this nitrogen here, I'm just going to kind of, there we go, come out like that, and say this nitrogen changed in terms of its charge, right? So we had 4 nitrogens here, 2 of them went in here and didn't get their charge changed, their oxidation number. 2 of them went in here and did. So those nitrogens, so we can say nitrogen is, now, obviously if copper is oxidized, we're going to say that nitrogen is reduced because one has to happen with the other. But let's make sure that we understand why. If you lose electrons, you go in the positive direction. If you gain electrons, you go in the negative direction. It's +5, if we have a number line, right? 0, 1, 2, 3, 4, 5. We're at 5, and we go to 4, we're going in the negative direction, right? We don't have to get to the negative numbers to be going in the negative direction. And so definitely he's going in the negative direction. Nitrogen is reduced. Look at that. Okay. Redox reactions. So much fun.